Right, so let's have a look at another partial fraction expansion. Now in this particular case I'm going to have a look at this particular one here. It's x squared plus 1 over x times x minus 1 squared. Now in this particular case what we've got to do is this. We've got to look at the fact that we've got an x minus 1 all squared here. So we've got to allow for every possibility of this particular part of the denominator here. So in other words, what we've got to do is divide this up into a over x anyway, because we have an x here. Then we've got to do b over x minus 1 to the power of 1. And then we've got to do a c over x minus 1 squared. So the general idea here is that, for example, let's say we have some expression as our numerator in x, and then let's say we have an x minus 1, I don't know, let's say to the power of 6 as our denominator. What you've got to do then is just write down, split this up into a over x minus 1 to the power of 1 plus b over x minus 1 to the power of 2 plus c over x minus 1 to the power of 3 plus, and so on, up to 6th letter of the alphabet is f, so it's f over x minus 1 to the power of 6. So you are accounting for every possibility of part of the denominator, this part of the denominator here. Okay, so we have an x minus 1 to the power of 2, so here we have an x minus 1 to the power of 1 and an x minus 1 to the power of 2. So let's just do what we have done in previous videos then. However, in this case we've got to work out what a, b and c would be. So let's start. We've got to add these three fractions first. So our common denominator is just x times x minus 1 squared, because this x minus 1 will divide into this x times x minus 1 times. So this x will divide in here x minus 1 squared times, so multiplied by a, that gives us a times x minus 1 squared. We have a plus here. Divide this x minus 1 in here, that gives us x times x minus 1. Multiply that by b, that gives me b times x minus 1. Divide this in here, that will just leave me with x. Multiply that x by c, so I end up with cx. Okay, so that's it really, but what we've got to do here now is look at the numerator. So we know that this is equal to x squared plus 1, or at least we want it to be equal to x squared plus 1 over x times x minus 1 squared. Now the denominators again are the same, so what we've got to do is look at the numerators, work out what a, b and c would be in order to give us this particular numerator. So let me just write that down first of all, and then we'll look at working it out. So we have a times x minus 1 squared plus bx times x minus 1 plus c times x, and we want that to be equal to x squared plus 1. Well, what I'm going to do here is just simply multiply the left hand side out. So I end up with a times x squared minus 2x plus 1 plus here I end up with bx squared minus bx, and then I've got a cx here, and I've got an x squared plus 1 on the right hand side. Finally, just multiply this part here out, you get ax squared minus 2ax plus a plus bx squared minus bx plus cx, and that's equal to x squared plus 1. Okay, so let's just put the x squareds together, the x's together, and the numbers then. And then what we're going to do is equate coefficients left and right hand side. So let's put these two here together. This one here has an x squared, and this one here has an x squared. So let's factorize as well. So we end up with a plus b and x squared outside here. Now let's see, let's have a look at this has an x, and this one here has an x here, and actually this one here has an x as well. So let's put those three together. So that's going to be plus, we've got minus 2a, we've got a minus b, and we have a plus c, and they're all multiplied by x's. Now the only term independent of x then is just this one here, so we've got a plus a out here at the end. All that's equal to x squared plus 1. Okay, so now here we have, if I write the right hand side slightly differently, it's going to be plus 0x plus 1. So now we have this quadratic expression on the left, something times x squared plus something times x plus a number equals this quadratic here, the same format on the right hand side. So we can equate coefficients here. So we need the a plus b to be equal to 1. This one here, there's a 1 here. We need minus 2a minus b plus c equal to 0, this 0 here, and then we know that a has to be equal to 1 then. So there are three equations, three unknowns, so let's see if we can work them out. Well, if a is equal to 1, that will give us 1 plus b is equal to 1. That will give me b is equal to 0. So if I know what a and b are, let's put them in here. We've got this one here, then will give me minus 2 times 1 minus b is 0 plus c equal to 0. So that will give me c, this is just minus 2 plus c equal to 0, so c is equal to 2. So now I know what a, b and c are. Okay, so that means then I can just write down my original three fractions as it was a over x, and remember a was 1, so that's just going to be 1 over x here, and then b was 0, so that's going to be just 0, and then we have c then is 2. C was 2 from what I can remember. Let me just double check that. Yes, c is 2 here, so that's going to be 2 over, and that had the x minus 1 squared part. So let's just test this just to see. This is our final answer here anyway. This is what my original fraction was, remember, x squared plus 1 over x times x minus 1 all squared here. So this is my answer here. These are the two fractions. They should add to give me this here. Let's just test to see if it does work. Hopefully it does anyway. Let's add these two. We can see the denominator is okay anyway. So we have x times x minus 1 squared. Well, x into all of this will give me x minus 1 squared plus x minus 1 squared into all of this will give me x, so I'll just end up with plus 2x on the top here. Okay, so let's just multiply this out. Well, this will give me x squared minus 2x plus 1, and here I'll end up with plus 2x as well, and on the bottom here we've got x times x minus 1 squared. You can see here that we've got a minus 2x, a plus 2x, so we do in fact end up with x squared plus 1 over x times x minus 1 all squared. So this here does work. This fraction here, when we decompose it, does give us these two fractions here.